everyone, and welcome to Jam Academy. In the last lesson, we did talk about the meaning and the definition of work. Now, in this lesson, I want to talk about the energy law, which itself is just the definition of work. Now, keep in mind that energy can neither be created nor destroyed. In other words, the total amount of energy in the universe is always constant. Now, if energy can neither be created nor destroyed, it means that for energy to be transferred into or out of a system, work must be done on or by that system. So, work done is equal to the amount of energy transferred into the system or out of the system. So, the energy law essentially states that the energy transferred into or out of the system is equal to the work done by or on the system. In other words, the energy transferred into or out of the system is equal to the work done on or by the system. This is the definition of work, and this is what we call the energy law. It embodies the law of conservation of energy. Let me show that to you. Now, if no work is done on a system, no energy is transferred into or outside of the system. We say that the system is closed. And if the system is closed, the total amount of energy in the system will always remain constant. In other words, for a closed system, W is equal to 0. This only occurs if the system is closed. Remember, when the system is closed, the system is isolated. An isolated system does not interact with its surroundings. And if an isolated system does not interact with its surroundings, then there are no external forces acting on the system. In other words, the sum of all the external forces acting on the system will be 0. In such a system, no energy is transferred into the system or out of the system. We say that the system is closed. And if that is true, it means that delta E total is equal to 0. This is the law of conservation of energy. But on the other hand, if the system is not isolated, in other words, if the system is non-isolated, then the work done is not equal to 0, in which case the amount of energy transferred into the system is equal to the work done on the system or the work done by the system. Remember, when work is done on the system, the total energy content of the system increases. That explains why the work done is positive. But when work is done by the system, the total energy content of the system decreases because energy is transferred out of the system. That explains why the work done is negative. So keep that in mind. So we can gladly see the importance of the energy law. Now, before we go ahead, there's one question that I would like for you to think about for a moment. Why is it that it has to be an external force to do work on the system? Why must it be an external force to do work on a system? Remember, work done is equal to the energy transferred into the system or out of the system. When work is done on the system, energy is transferred into the system. But when work is done by the system, energy is transferred out of the system. In that case, the work done is negative. Now, by Newton's third law, forces are generated in pairs. Keep in mind that a force is really due to the interaction that occurs between two objects. If I'm pressing my two hands, my right and my left hand are interacting with each other by virtue of Newton's third law of motion. My left hand exerts a force on my right hand, and my right hand exerts a force on my left hand. By virtue of Newton's third law of motion, the forces are equal in magnitude but oppositely directed. Which means that at any time t, the sum of all the internal forces acting on a system is equal to 0. And by Newton's second law, by Newton's third law, the net internal force acting on the system is 0. That means that the motion of a system can only be due to external forces. Can only be due to external forces. That explains why the work done on or by a system is only due to external forces. But the question is, if an external force is acting on a system, will it always lead to work done? The answer is no. I illustrated above. For example, if our system is this rock, let's say this rock is our system. This guy is pushing on the system, but the displacement of the point of application is 0. And if there is no force displacement, there is no work, even though there exists an external force. So the presence of an external force is no guarantee that work will be done. Work can only be done provided there is a displacement of the point of application of the force. We call that a force displacement. Thank you so much, and if you have any question, please do not hesitate to ask in the discussion forum below. Remain blessed, and bye-bye.